Sweet. It looks like we have a couple demos today. I'm just looking at the meeting notes agenda that I can paste in the chat. Sean, are you? Yeah, there you are. I'm going to move you under Josh and Trishank.
Sure. Yeah.
Sweet. Cool. All right, let's kick it off. Joshua, Locke, and Trishank, do you want to kick it off with your?
Great. Yeah.
I think it's a demo, right? Or discussion?
It's a discussion. Sorry, guys, no demo yet, but hopefully, once we solidify discussion a bit, we can show you some nice demos. Joshua, feel free to would you mind presenting a bit? I'll do the introduction, lead a bit, and then I can take over from concepts. What do you think? Hello?
Oh shoot, is he not here? Okay.
Yeah, no worries. I can do the whole thing. Okay. So the problem is there's a ticket open for it. It's called SLSA 101. I'm sure we have a more readable name for it. But the basic idea is, how do we distribute these attestations? They are certainly signed by some keys. And the problem is, okay, let's give you a visual example of the problem. So we've got all these artifacts. We've got statements about the artifacts. We've got signed envelopes about the attestations, and at the end, what you're doing is shipping a bundle of attestations, and each of this attestation could map to something like a job in your CI/CD pipeline, right? And you might even bundle the artifact together, actually. So by the end of the day, what you want to do is know, okay, somebody signed the attestation. Why should I trust it? That's the problem we're having now, the bootstrapping chicken and egg trust problem. Okay, and what we basically proposed, too long didn't read. How do I share this article with all of you? Anyone on the internet, this link in comment. Okay, great. So let me paste the link in here so that people can start commenting right away. This is what we want people to do, and I'll paste it in the chat here too. Great. Okay. So there's some goals, right? So that's the context. Now there's some goals for this. We want a mechanism, a simple yet powerful mechanism to discover public keys used to verify SLSA attestations. And we want to reduce the need for complex key management, right? You want some properties of key management, like maybe you want keys to expire, maybe you want things like threshold signatures, maybe you want to say things like 3 out of 5 of these keys must sign for the attestations, and you want key revocation built into the system because keys get lost and stolen and whatnot. Okay, so what we recommend is basically something that we tentatively call in toto policies, and the idea is as follows. If you've seen in toto layouts, the idea is very similar. So you can kind of think of in toto layouts. Okay, so SLSA has got something called in toto attestations, right? In the classic in toto world, they are called links. Now, you can think of attestations as generalizations of the links idea. A link is just another predicate, if I got the terminology correctly, in the world of in toto attestations. So similarly, we're taking in toto links. Let me pull that out, actually, instead of hand waving. And so in the world of in toto, you basically have all of these links, which in SLSA, they map to attestations. Okay, so just think of this as attestations. Now, what you're looking at this picture, you can think of this as, this is what in toto calls a layout. This is the pictorial form of a layout, and we're calling it a policy. And there's some very important differences. Now, all the policy says is there are all of these steps in my pipeline, and each one will produce an attestation, and they will use certain keys. So for example, oh, Diana's going to use a set of keys, and Bob's going to use a different set of keys, and so on. Now, we're not going to do anything as complicated as inspection at all. That's not the point. And this is where we stop. This is really the important thing. We're stealing the idea of in toto layouts to basically, one, talk about the shape of your pipeline. What do the jobs, what do the steps, forget jobs, what do the steps of your supply chain look like, number one. Number two, in each step, who I'm sorry, what keys are trusted to sign that attestation? Does this all make sense so far? Great. Feel free to stop me and interrupt me anytime with questions. So that's really it. It's just a higher level layer above attestations where we break down, we break the pipeline down into steps. There are no inspections. We break things down into steps and simply map for now which keys are allowed to sign which attestations. That's it. That's the high level idea. Now, the only thing we need to worry about next, if everyone is amenable, okay, so why do this? Why use in-toto, why borrow from in-toto layouts at all without doing something called inspections? First of all, we like the idea that the rich key management model it has in there. You can do things like threshold signatures. You can make the policy expire so you don't trust it indefinitely. And we want to open the door in the future to something like inspections if the community so desires. But I don't think, well, at least we don't have to worry about it pre-version 1.0, I think, until we do more complicated things. Inspections are just a way to do Turing complete checks of how your pipeline is supposed to behave. Just think of it like, just think of inspection as a function. Okay, it's a function f, and x is all of the source code and things like that. F is what your pipeline is supposed to do. You get an artifact called y, and by defining this inspection, the pipeline cannot misbehave. That's it. But like I said, we're not worrying about this now. All we're doing with policies right now is using it purely for key management. Great. Does this all make sense so far? Good. Now there's only one little problem left, which is that the policy itself is self-signed. So that makes it interesting, because then the question becomes, okay, I need the policy to tell me which attestations which keys I should use to verify each of the attestations. And you can do a simple thing like all attestations are signed by one key. Sure, why not? Or if you're really worried about separation of duties, you can have each of the attestation produced by different steps and produced by literally different, could be different people, could be different machines, and so on. Great. So just like in-toto policies, in-toto layouts, in-toto policies are also self-signed. So we have solved the problem of distributing many keys for attestations, but now we have to worry about how to securely bootstrap the initial set of keys that you need to trust the in-toto policy. For that, we're still working on it. That is not the point of the discussion today. Joshua and I are working on several policies, several recommendations, which we've not fully thought about and finished yet. So that's work coming, but we want to focus on one problem at a time. We want to get consensus on policies before we even discuss how do you securely bootstrap policies, because otherwise it doesn't make sense about, we should first nail this problem before nailing this one. Great, I'll stop here, and I already see there's some questions. Let me try to answer them. Jack said, life model, all crypto systems are key. Yes, this is true. I can watch from personal experience. Okay, great. So we have consensus there. We're done, no?
Can you clarify what you mean by you want to solve the question of policies first? I didn't quite follow that part.
Oh, sure. So in SLSA, we have attestations. This is very well defined and accepted, right? Basically it's accepted. A policy is a new concept that we're proposing to SLSA. So we have all of these concepts in SLSA well defined and accepted so far. We're introducing a new concept called policy that we have a definition for in here. And we want to get consensus on whether this is a good step forward as a general mechanism for distributing keys for SLSA attestations. Make sense?
So this is independent of the specific layout. This is simply a way to have granular claims being made and signed by different keys, and then a way to specify and check that after the fact to see whether or not it complies to the policy.
Correct, exactly. You can think of it as a way to compose what your pipeline looks like, which I think SLSA doesn't yet have right now. I could be mistaken. Someone please correct me if I'm wrong. I see Mark has raised his hand. Let me quickly finish this point. Yes, it's a way to compose what the shape of your pipeline looks like right now. That is the way to think about it. Mark, go ahead.
Yeah, I think it would help to write out what the use cases are and like what problems this is solving, because that's not clear to me right now. This is proposing a particular implementation, but I think SLSA could be used in a variety of different contexts. And so it'd be good to go through like a specific example of so for one, would this be used within a company for like their first party builds, or would this be used for open source projects, or maybe multiple? And if you could describe like, here is the properties we want to verify, and here is, or like the invariance we want to ensure through SLSA, and here is how this thing accomplishes that or plays a piece in accomplishing that. I think that would help, because I'm having a difficult time like making that connection.
Okay, yeah, no, that's a fair comment. Joshua and I can easily work on that. Sure, yeah, and I think it's also worth distinguishing between private and public use cases. Yeah, this doesn't have to take a lot of time, really. It's actually a very simple idea. It's just something higher level. This is literally what the policy looks like. We already have the attestation, and all the policy says is, hey, for example, I expire on this date and time. Don't trust me beyond that. Here's a README for what I'm about. Here are all the keys used for all of the attestations. And then in each step, you would give it a name. You would give it a threshold of signatures and just say, refer which key ID you mean are used to verify each attestation. The attestation for the step as specified here. So all of the keys are mapped earlier beforehand, and then for each step you just map and say, hey, I want a threshold of these keys to sign off on this attestation. That's it. It's very simple. It's deadly simple.
Could I ask a clarifying question, maybe?
Sure.
So is this sort of like I'm trying to like sort of parse the proposal. It's kind of like a new format implementation that other people can understand using the same update principles that Tuf does for the rest of the metadata, like normal metadata in normal Tuf distribution. And this basically formats metadata that's understandable to clients using SLSA. Like, as in, I could probably achieve this with a fancy combination of Tuf targets and delegations with custom metadata that points to the key IDs and steps, but this like bundles this all nicely into something understandable by clients.
Yeah, and in fact, is that you, Azra?
Yeah.
Hi. Sorry, because I'm not able to see who was talking. So yes, that's a great comment. Thanks. So all of this so far, although it looks very similar to Tuf, because that's what Tuf and Intoto share. They share a lot about how they talk about keys. Literally has nothing to do with Tuf yet. That comes at the end here. We haven't talked about how to securely bundle the policies and the policies and attestation, the bundles actually. So far, we're just reusing the same key distribution mechanism. This is all Intoto stuff actually. If you look at Intoto layouts today, the original Intoto, it looks exactly the same, except for a few things we've removed to simplify the problem right now.
Gotcha. I think so. There's so many hands, but thank you so much for addressing that.
Sure. Yeah. Sorry, I think Brandon's next.
Yeah. Hey, Trishan and Joshua. So I think one of the things that kind of I had a question about is like what the extent of the policy is, whether it's just for attestations or should it go deeper into it, because there are like so many ways in which you can use keys to extend the trust, and I think I'm trying to figure out what what do you envision? Are these like only root keys plus the X509 chains, or is there a need to configure how certain keys are being used and so on?
That's actually a very good question. So in fact, if you look at IT today, there's several, so nothing here so far. I should clarify, nothing here. The reason why we're bringing policies that is actually very neutral about how you distribute, let's say the root keys of the system. Very good, excellent. You can think of policy as your in toto root keys. And then you can reuse X509. In fact, if you look at IT 7, I think there's already a proposal, yeah, on draft. So you can use X509 if your company is already using it internally to sign off and to sign off on this policy. So that's what we're working on next. Try to roughly answer David's question. Option number 2 here will clearly be things like X509, or option number 3 might be, oh, I don't know, 6-door wrecker. Yeah, there's certainly several options. Make sense?
Yeah, so I'm guessing this is just kind of for attestations, right? Other than that, that would be, it will handle itself in terms of other signing keys that, you know, it gets chained from the attestation.
Yeah,
I think
wanna
it
make
answers the
sorry?
question.
Okay, great.
Yeah.
So thanks. I'll make a point of it. I think we should add that we want to make existing key distribution mechanisms possible, reusable. Okay, great. I'm sorry, there's several people waiting. Sean?
Yeah, my question was essentially the same. It was just about kind of root key distribution, but I guess that's, yeah, we've already covered that.
Correct. That's the thing that I was hesitant to go on today, because I wanted to say, do we agree on this format to sort of like distribute the keys to the system, including the root keys? And then we can go from there. I see David shaking his head, so.
Yeah, I mean, I think there's several different things here. First of all, I do want to foot stomp on an agreement with what Mark Lodata said. You know, what's the use case? What's the problem you're trying to solve? You know, drilling into here's the format of the JSON. Don't care if it's not solving a problem. And I think more specifically, I'm deeply uncomfortable with mandating a particular format unless it's absolutely vital to do so. I'm not saying it's never a good idea, but you know, I think the goal is what's the requirement for what are you trying to accomplish, why, and then hey, here's a format that might be useful to do that. If it's going to be mandated, that's a whole different level of pain. I mean, right now there's a should on in toto, and even that may be a little too strong. So, you know, I'm not saying it's never a good idea. Just, you know, wait a minute. You know, that's you know, we want people to have strong supply chain, you know, strong supply chain integrity. The exact formatting on how they represent that, is it really critical we have everybody use exactly the same format? I don't think so. Maybe, but you're going to have to do a much stronger argument on why it's necessary and how and why this one is the right sole answer.
Yeah, no, that's a very good comment. Yeah, maybe I'm not sure whether we said must here, but if we were not careful in making sure that this is a recommendation, we will certainly clarify that. Yeah.
First of all, I'm not even. Let's start with this might be a way to do it. Here is one way you could do it. How's that? If you're going from there to this is the one true way, or this is the way we want everybody to do it, I think you need a strong argument for it. I'm not saying you can't make it, but just you're going to need a good one. Right now, I'm not even sure I understand the use cases right now. So, you know, that not even being sure what the problem is you're solving and makes it really hard for me to believe. And this is the one way it must be done. If that makes any sense.
Yeah, we'll make that clearer. I think yeah, that's fair criticism. We did not make clearer what probably the context of the problem was. So I think something like use cases would be a much better narrative.
You know, What's the problem? Why
and
does it solve it? Here's the use cases. I mean, you may have that in your head. It's not clear from looking at this.
absolutely. That's the problem with technical writing. It's perfectly clear in my head, but not to us.
Yes, yes. We've all been there, so I'm sympathetic to that problem.
Yeah, and so we should also make it clear that yes, we're not mandating anything. This is the same level of prescription as attestations are, but we'll make it clear. Sorry, before I forget, Michael, I think had a comment. Although it seems to, oh, there we go.
Yeah, I'm sort of meandering my way through this and trying to figure things out. I think that what David said is probably more articulate than what I would have said, but I look at the various tool chains, and I think that, you talked about this as SLSA key distribution. I think this is a key distribution mechanism that fits into one of the possible tool chains around the SLSA framework. David said it much better than I did. I'll back off. Thanks.
Okay, so I think where we failed was in defining the use cases a lot clearer. We'll definitely make progress in that one.
Just to be very direct, calling this SLSA key distribution puts the frame of the reader in, this is now mandated as part of thing. Whereas a key distribution solution called Fred that works really well with framework SLSA in concert with the in-toto attestation details, that changes everything you just said still fits, but now you've contextualized it to being one of the many ways that this can be done per David's eloquent speech.
Wow, I'm not sure I was quite that elegant, but thank you. Yeah,
well, I'm going to be asking you for a favor later on, David, so I'm buttering you up.
Oh my gosh. Yeah, so a way to use in toto to support SLSA, I mean, something like that. I think Mike Windsor's exactly right, though. The title immediately gets you off on the wrong foot. And I would also add, you mentioned use cases. You said use cases several times, but I think it's important to note that both Mark and I didn't just say use cases. We said, what's the problem you're trying to solve? And then the use cases. Because I actually don't care. I still don't care about use cases unless you make it clearer what is the attack or what's the reason that you need this. I think that you've got, I think you've got it in your head, but it's not showing up. Well, at least it's not clear to me. How's that? It may be a problem on my end, but it's not immediately clear to me.
Sure.
And I understand, hey, we need to have key distribution. I got that, but more specific than.
Okay, sounds good. Yep. All good constructive comments. Great. Anything else? I don't see any more hands. I think Michael's already, yeah.
Oh, I apologize. Yeah, I'll pull it down. I'm used to it going down automatically, and what the heck?
Great. Okay, so so how should we discuss this going forward? Do we continue on a GitHub ticket, or do we should we have I don't know, another discussion, I don't know, 2 weeks from now, whenever it is Joshua and I. What's the recommendation?
I think that building on David's feedback of contextualizing this work with a clear understanding of the problem for people to, as is often the case, right? We blur the solution, the problem, the name, and the branding, and the various other efforts. I think come back in a couple of weeks with a clear articulation of the problem, and then fleshing out from there would be fantastic. That's just my preference. I'd love to see it that way, but I'm not speaking canon here. I'm just suggesting how I would see progress.
Okay, sounds good. Yeah, and I don't want to take up too much time either. So next time, thanks a lot, everyone.
Thank you.
Yeah, I think this actually gets into, I know we have other things on the agenda, but because it's salient to this conversation, we have an open issue about having an enhancement proposal process. I forget what issue number it is. And I feel like this would be a good candidate for that, where we have various folks who are, it's not necessarily changing SLSA itself, but we want to get feedback on some idea in the SLSA ecosystem. And it would be valuable to have a way to loop in other people who are interested and want to participate and contribute, either by writing it or reviewing or generating ideas or et cetera. So if you have comments on that, please chime in. I think this would be a great use case for that. And for like this particular one, at least until that process gets established, I might recommend that like folks who are interested in this, like either being reviewers or contributing to ideas, could maybe tag themselves in the doc or contact Trishank some other way. And like kind of iterating in that smaller group. And then once it kind of like fleshes out ideas, we could present to the larger group again.
Cool. Looks like Trishank is on board with that. Are these called SEPs, S-E-P?
Yeah, I was
Schlep.
like, so Jacques got schlepped? No, that's terrible. Please, no.
Schlep. I like it. Cool. Awesome. Trishank, this was great. Thanks for kicking this discussion off.
Thanks, everyone.
Sean, you are up next.
Awesome. Okay, let me share my screen here.
Maybe just give a quick high-level background for folks that weren't on the call maybe last week, what you're going to
Sure.
do.
So going to be demoing the Active State platform, which is our kind of build system for pretty much, or the aim is to go for as much of the open source ecosystem as we can. I mean, we're starting out with our traditional ecosystems, which are Perl, Python, and now we're moving out into Ruby, and there's some Java work on the horizon. So we're kind of slowly working our way through all the kind of major ecosystems. So what we're attempting to do today is I'm going to show you kind of a demo of how the platform works for building a Perl distribution. So here's one I built earlier, which literally just contains the Perl core and the Perl's core dependencies on Linux. So it has Linux and Windows configured in. And what I'm going to do is I'm going to add a couple of packages from our catalog. So let's add socket SSL. It's the auto version, which basically picks out the latest appropriate version based on all the other constraints you've got in the system. So you'll notice that we've kind of populated some additional dependencies here. When we brought this in, what happened is we went out to our component called the solver, which is our SAT solver for doing dependency resolution. It then picked out everything. So it goes across and it picks out all of the dependencies required for that module in the Perl ecosystem. But we go one level deeper in that we will then pick up things like libxcrypt, which is required to make sure that we're compatible with all the different versions of Linux that you can install this on. We're also going to need OpenSSL and zlib. So we actually go down to pick out things that aren't necessarily part of a bare bones distribution, and we'll add those in as well. And I'll show you how that kind of affects how you install this as we go on. So I'm going to commit these changes. So that's my project updated, and then click to view status, and that'll take us to downloading builds. So what just happened there? We then made a request to our build farm to go and build these two things, and it went off and discovered that we'd already built all these things, and basically delivered us cached output from previous builds. So we can take a quick look at perhaps one of the logs. Let's have a look at IO socket SSL. Actually, let's have a look at net SSL EAY, because that brings up some interesting questions.
Can I just
So you can
second? Do you mind just giving like a 1 minute context on, again, on the problem that you're trying to solve here?
Okay, so what we're trying to do is provide people a way to build runtime environments from open source components so that they can then develop on top of those. It's basically dealing with dependency hell. It's dealing with making sure that you get consistent, trusted builds, and it's and we kind of wrapping up all of this kind of some of the stuff that comes out of SLSA, like the hermetic builds, the parameterless builds, and all of those kind of things are things that we've been thinking about for a while, and we've kind of brought together into this framework so that Eventually, the idea is that you'll be able to kind of build any piece of open source with the platform, and you will be able to use it as a foundation for the development that you're doing on top.
Got it. So a SLSA compliant open source and build system, essentially.
So
Essentially, yeah.
Okay.
you're trying to solve the problem of instead of relying upon the binaries published by the maintainers in their releases, you're building from source for your entire dependency tree.
Exactly.
Got it.
Yes. So
Thank
yeah,
you.
we download, we ingest source, we verify the source, we maintain all the metadata about the source. So we have an offline cache of all the source that we build, and that you can see. Well, you can see a little bit here in how it's working. So the first thing that it does is it downloads a builder. So that's our build script. And in these downloading, it also validates them against their checksums. We then download into, so this is running, each one of these builds is running an isolated container. That container is bare bones. It doesn't contain anything else from the build out of the box. So we provide it with a configuration file to say, okay, well, this is what you're building. This is what you're building it with. And these are its build time dependencies. And then the build time dependencies are downloaded individually into this container. So you can see it's downloading a whole bunch. It's downloading some patches. And you see, yeah, it's bringing down, like, okay, so that it needs the Mozilla CA in order to fulfill net SSLEA way. So all the build time dependencies are there. Some of the things that we do as well, which I've got some questions about later, which I'll bring up in a bit, is because we build in these isolated directories, quite often, well, in fact, yeah, for a large number of our ingredients, we need to relocate them on install. So basically we do things like, okay, so if you've got paths burnt into something like Perl's lib/config-heavy.pl, they will typically represent the build environment. And what we need to do is when we come to deploy them, we can't rely on something like the way that Nixos does it with a symlink farm, because this one is being done on Windows and symlinks just don't work on Windows. So we actually rewrite some parts of the artifact on deployment. But yeah, you can see it kind of downloading all the dependencies here. And then we run our builder. This runs, in this case, it's a bootstrap script called build.bat. And these parameters here are drawn from our constrained set of parameters that you can provide to builders. So we have for this one, we need to tell net SSLEAY where to find the OpenSSL library. So we do this with an environment variable that is understood by the builder for net SSLEAY. And then the builder basically bootstraps running the makefile.pl.
Could I ask a
Sean?
quick question?
Sure.
Oh, David, go ahead.
Okay, I was just gonna ask, would you argue that your current environment meets SLSA, say SLSA 1?
I think we could get as far as SLSA 3. I think the problem that we have is we have an ingestion problem in that we cannot take attestations for the source provenance too well at the moment. We don't know whether, for example, the repo is configured for multiple reviewers. So that level, you know, we're kind of a step up in the chain from there, and we don't necessarily know. And at the moment, we can't extract the information about commits or pull requests or any of that configuration about how the source code works or how the source code has been created and released. So that we still struggle with a little bit. And at the moment, we don't do kind of any of the attestation part. So although that's something that we're planning to kind of build in, I think, you know, in terms of the spirit of it, we've got the mechanics to do everything to SLSA level 3, maybe even SLSA level 4. But at the moment, we can't even really claim SLSA level 1 because we don't have the data on the source code that we've ingested to the right level of detail, and we're not providing attestations about what we're doing.
Gotcha. Mark, I didn't mean to cut you off, so please ask. Mark?
Yeah, yes. So yeah, I guess for that particular point, I think also, just as a reminder, the SLSA spec doesn't require any particular format. So if the data is there and it kind of meets the requirements, I feel like we should clarify in the spec that if an organization is doing this and achieving, effectively meeting the levels and stopping the threats, if it doesn't have to be in any particular format, as long as kind of whoever's consuming it and it, has
Invalidate
accepted in that format. I had a question. You said something about rewriting something or other on deployment,
Yes.
and I didn't follow that. Could you go into a little bit more detail?
Yes. So, for example, so what we're doing here is we will build. Let me see if I can show you. Yeah, we will build into an isolated directory. So when we build our output, let's take a look at where the output goes. For this particular build, we have an isolated output directory which goes into this outputs directory, which is unique. And so all of the code that we build gets deployed there during the build. When you come to deploy it on a user's machine, or when you want to come to consume that artifact in any other way, any paths that are hard-coded into the artifact as part of the natural build. So for example, Perl bundles in a whole bunch of things about, paths to compilers, paths to where the Perl core lives, and things like that. They're all in a config file. We take that, we have information about that config file and where it has hard-coded paths and how they should be rewritten. And we write that into a metadata file that we put inside the artifact. So come deployment time, when you come to unpack the artifact, you unpack it to wherever you want to unpack it, but then you have to run a relocation step that rewrites all of those paths so that the artifact actually works when you run it. Did I kind of explain it a bit?
Yeah, so is this for, so this is for cases where there's some hard-coded path in the build process. Ideally there would not be such a path, but this is a workaround for cases where there is.
Yeah, I mean, we find that there are a lot. I mean, even going down to C libraries like libxml, libxml2 comes with a little config script called xml2 or xmlconfig.sh that you run to find out what your link line would be. And so similar for package config files, where if you want to do package config libs, whatever library, and it will tell you which libraries you want to link against so that you can get a full, you can get a full link of something. Those things typically have hard-coded paths burnt into them. And we need to rewrite them so that they're accurate for the deployed environment. So that was, that was one of the questions I had is, does that step need its own kind of attestation? But yeah, we'll come to that a little bit in a bit. So
yeah, I see. So am I correct in interpreting this as that is a complementary piece, but it's not required? Like if you're building things that don't have such hard-coded paths in it?
Yes. Yeah. I mean, we only do it for those things that do. I mean, you can see that, there's we rewrite some files from some of the distributions, but others we don't. So yeah, there's a whole bunch here where we don't do any rewriting, and here we do kind of some of that because our build system not only produces the artifacts, but it consumes them as inputs to other builds. We have to do that. We have to do that relocation on build as well. So yeah, you'll see it happening in here, and you'll see the actual tool that we use to deploy it. I think it's probably true of any installation mechanism where you will make modifications to the things that you're deploying, partly based on where you're deploying them and partly based on other things that are specific to the environment you're deploying in. So anyway, this gets us to net SLSA and everything else having been built. Here's another thing where another case where hermeticity is something we might end up breaking, as we discussed last week. Sometimes test suites require you to break out of the hermeticity. So at the moment, we're modeling tests as a separate step so that we can give the tests their own security requirements, so that if we do want to run them, we can run them with degraded security in order to allow them to do what they need to do. So that gets us to a build. That build is essentially the same modules with slight variations for platform compatibility on all the platforms you put in. And you can put in, there's a variety of different Linuxes, there's Windows, there's Mac as well, which supports a variety of macOS releases. Once you've actually built this, how do you actually get it onto your machine? Oh, I want to demonstrate one other thing. That we've got an experimental feature that we've got at the moment, which we're working on at the moment, which is generating software bill of materials for any build. So we have an endpoint with our mediator, which is a GraphQL endpoint for the platform, where I can say, okay, well, this is my organization, which is basically here, and the name of my project, and I'll put that in there. And then basically I can then go and ask for, this is our prototype SBOM, which will then tell you all about the kind of all of the components that are in there and the relationships between them. Again, we're still, one of the things that we're still looking at, which is why I was interested in Trashank's presentation, is selecting a PKI for signing these things and for signing our artifacts. So yeah, we're working on that too. But yeah, there's mechanism that we've got built in based on the metadata that we hold about all of these things, that we can generate software bill of materials. Okay, let's deal with getting these things installed. So we have a client-side tool called the state tool, and I can activate. That's my project on the platform. So the idea of these is that we are initially generating completely virtualizable environments. So something like pipenv, something like Perl brew, or something like that. We're building virtualized environments for running your distributions, and those include the kind of the lower level dependencies as well. Whereas Perl brew and pipenv will only take you down to those components that live within the ecosystem. We will take you down to the C libraries as well. So we're virtualizing. We can virtualize, MySQL. We can virtualize Postgres. We can, as part of all of these things, we'll virtualize all the way down to the level that we build. So, what do we get? We put IO socket SSL. We have a Perl runtime there. And that'll be the same on Linux. Hopefully I've got a clean one here. This one is, again, going back to our solver. This one hasn't actually downloaded, but then basically because of all of those individual items were built as separate artifacts, it downloads them all and installs them all. And so basically, in terms of using it in a CI/CD pipeline, we keep our caches pretty warm. So if you wanted a consistent runtime for your project, usually it's just a few seconds of download away. And again, it's completely virtualized. One of the things that we do on Linux, at least, is we are quite cunning with things like R paths, so that we don't have to set LD library path as part of our virtual environments. So yeah, you can pull in IO socket SSL, for example, without having to set LD library path. Pretty sure this runtime doesn't set it. No, it doesn't.
I vaguely remember that being controversial, setting our paths.
It is and it isn't.
I mean, I think Red Hat forbids it, so in their packaging system.
LD library path overrides our path, so you can use it in preference. But we have customers who are already using LD library path, and so they are doing that for their own reasons and for their own libraries. And so to avoid interfering with that and having to modify their LD library path on top, we burn our paths in so that everything is internally consistent. And we burn them. We don't burn them in as full paths. We burn them in as relative paths to $origin. so that it doesn't matter where you deploy the runtime, it's always consistent.
I had just a
So-
follow-up question on a point you made before, which is you mentioned that like you don't have the ability to verify, for example, if a project has two approvers, right, and things like
Mhm.
that around the actual project. So my understanding was that SLSA is not transitive, right? So are you
Right.
implying that you need to know that about all the things that you're building, or just what you're
think we
actually building
do.
on the platform?
Yeah, so my understanding was that that how transitive dependencies affect salsa levels is still something that's under discussion, and I think
Okay, I
there's-
just read the docs. I wasn't aware
Yeah.
that there's stuff underneath the
I
chart.
think there's some interesting nuances around that.
Yeah, I mean, it sounds like a not
It's-
very
I think-
valuable assertion to say that just the top level thing is secure if nothing underneath is secure. So I can understand the discussion. Yeah.
Yeah, so I mean, I think the other thing that we're discovering as well is that if we do start to have transitive effects of salsa levels, you then have to worry. You start to think about closures within delivered artifacts, because you may say, okay, well, this entire build that I've got here, not everything depends on everything else. So you couldn't necessarily say, okay, there is one salsa level that applies to this entire build, because you may have different salsa levels for all of the individual components, and if they have transitive relationships, and that affects their salsa level, you can't say as much about each. Well, you can say more about the ones that appear at the top level, but because they're not necessarily related. If I added another package, so if I added, say, for example, DBI, the database connectors, that's not necessarily related to IOSocket SSL, and we might get a complete build of IOSocket SSL, which is salsa level 4, but because some dependency of DBI is only salsa level 3, if it has a transitive effect on DBI's level, that's a different closure, and so it has a different salsa level. So this build may well have different salsa levels within it.
Yeah. Understand. And just to be clear, like a lot of this stuff, right, it'll be hosted on GitHub or other places, but then you'll just kind of take a copy when you're building it.
So what we currently do is we draw the source direct from the ecosystem repository. So wherever the ecosystem tells us these are, that's where we get them from. So for Perl, we'll get them from CPAN, or we'll at least get the locations from CPAN. And for PyPI, the same. If the source code is uploaded, we'll get it from PyPI. The underlying things that don't have an ecosystem, like the C libraries, we will get direct from their source repositories.
Got it. And do you have any thoughts on the security of getting it from like an artifact repo that happens to have source code versus getting it from the actual source code repo?
Yes, some of those repos don't actually contain anything like a checksum or a digital signature for these things. So we are looking at now, because we get one of the things that we scrape off the repos is the source code repository, where it's available. Then we're starting to look at moving the ingestion pipeline such that it will look further back. So it will go back to GitHub and go and get artifacts from GitHub, or go and get source artifacts from GitHub. And there we will get checksums and potentially GPG signatures that we can validate. So we're looking at, that's something that we're kind of extending out to now. But initially, all of our pointers are coming from the ecosystems, because that's the one central place we can go and get everything.
Got it. And sorry, one more question. So the idea here is like this active state platform, right? You'll build it once, and then you might have hundreds or thousands of consumers of that securely built package, not for everybody to like kind of do it on their own, which is what the industry's been doing until now, right?
Yeah, exactly. It's basically being the kind of the underpinnings of the CI/CD for all of the open source components.
Got it. Right, secure SDLC or secure supply chain as a service in a certain sense, where you get an artifact that's actually signed that took care of all the building from source for you.
Yep, and I was wondering as well whether the log files that we actually collect are also valuable data. I mean, we think they are, but and some of our users think they are. We wondered whether this was additional evidence about us having done what we said we'd do in an attestation, and whether logs should be treated as artifacts in their own right.
Got it. It's very helpful. Thank you.
Okay, Mark, you have another question?
Sorry, forgot to lower the hand.
Chapter, I think so. Okay, so yeah, I think that kind of shows where we're coming from, and the ideas we had before we even kind of came across SLSA. We were drawing from things like Nix, things like Bazel. We're looking at kind of hermeticity, reproducibility, and guaranteeing that sort of thing, and making sure that our environment provided everything needed to do that. And then then we threw Perl and Python at it and discovered that some of those things aren't quite as nice and hermetic as you might think. So yeah, and we're working around that. We've found a case. I think the only case so far we've got is test suites and authenticode signing are the two things that we can't do hermetically at the moment. Okay, any other questions?
Yeah, for test suites, could you distinguish between maybe tests that are like critical and actually are testing things that are important, right? Like I'm saying from a security perspective versus and actually having that network access could be harmful because somebody could go in and make the test succeed where it really should have failed,
Yeah.
versus maybe tests that are just more like feature specific.
Yeah,
It's
so we
hard.
have,
Yeah.
it's hard. I think, for things like, okay, the IO socket SSL one, we would have to, kind of build a sandbox, and that we could do that, and we would have to potentially do that for everything that went outside. So at the moment we're starting to do some monitoring on our build instances to make sure that, where we're denying egress, we're recording it so that we know which packages are trying to get out onto the internet to do certain things. Yeah, and like I mentioned, I think before, we're treating running the tests as a separate build step, and so the output of that build step is a set of test results that we will probably treat as a separate artifact in its own right as well.
Got it. I guess it might be useful perhaps to run with allowing network access and then without allowing network access, and then on one side you have some tests that might fail, on the other side that it's secure. Just a thought.
Yeah, that's interesting. I'll take that away. David, you have your hand up.
I actually have a similar question. I mean, I would be, well, we're running out of time, but I would love to have some idea of some categories of, here's where the hermetic stuff doesn't work because, I mean, there's already discussion in there. The hermetic stuff has its place. If it's too hard, can we separate out the things that are important and the things that are less important? In particular, things that might produce a different build. Hermeticity obviously makes more sense. Maybe for certain kinds of tests, as long as they don't affect the build result, they may affect the test result, but they won't affect the build result. So it would be helpful to have more information about what's actually going on, so that there is the question about what should there be tweaks to the SLSA definitions. But first step is, what's the real world situation? So we don't want to back off where it doesn't make sense, but maybe we do need to back off.
Yeah, I mean, we're gathering that information now. So that's part of the thing we're doing with our egress monitoring, is to see whether these things, so far we don't have anything that fails to build that we haven't been able to work around. So like Perl's alien ecosystem, so there's like an alien libxml, they're kind of shims to pull in external libraries. So there'll be alien libxml, which goes off and literally downloads the source code to libxml2 and builds it in line. So there are things like that we've been able to we've nerfed and removed their ability to go out to the internet to do these things, and prevented their necessity for doing so by providing the underlying dependencies. Anything else that we can't do hermetically, we are carving out into separate build steps, so that things like authenticode signing, the initial idea was that we would do that inline in the container, but because it's non-hermetic, and because we want to also have different security requirements on the node in the cluster that manages the key material, we split those out into a separate step that runs on a different node. So things like that, we are carving these things out so that, the core of our builds are always as hermetic as we can make them. But where we get other use cases, we're carving them out into separate build steps. And as we gather the information, then yeah, I'm happy to kind of provide that feedback on what use cases we have that are not reasonably achievable hermetically.
Well, thanks, Sean. This is awesome. Good discussion too. Tom, I'm going to give you the last 5 minutes if you want to follow up with anything Tom said or want to plug your the request for comment. I'm not sure if you want to screen share, but I can copy that in the chat.
Yeah. I don't know how much. Well, let me see about a screen share. Generally, this is a PR that defines an attestation format that can communicate what SLSA level a given artifact someone else has certified that artifact as meeting, and in addition, it captures the SLSA, the transitive SLSA level of the dependencies of those artifacts, so that with this attestation you can say, okay, the top level artifact is SLSA 3, and it has the minimum transitive level of all of its dependencies is SLSA 2, for example. This has a couple of advantages which are described in the PR. I think one of the use cases is what Sean was showing us earlier, where there are all of these different build steps that different SLSA levels might apply to different steps, and that it lets you make the decision in one place and then reference that decision later without needing to bring all of the evidence along for all of the dependencies in the entire build graph, which can be very cumbersome. So please take a look and provide any comments.
Cool. Awesome. Well, I think I'll give you guys 2 minutes back. Thanks, everyone. We can try to do some more intros next week or next meeting if we have some time. I think we already are lining up a few more demos for next meeting, and hope you all have a great day.
Sounds great. Thank you, everybody.
Thank you. Bye.